Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge in Tribonacci number. So basically this question is base question whoever is starting with DP. So now let us go ahead at what exactly this question is and then about how we are required to do this question. So 1 minute is coming up right. Okay. So here the Tribonacci sequence Tn is defined as follow. T0 equals to 0, t1 equals to 1, t2 equals to 1, and then tn plus 3 equals to tn plus tn plus 1 plus tn plus 2. So basically whatever last three numbers which would be there, that we are required to add up, and then that will become our tn plus 3 term. So that's the thing here. And this will hold true for all n greater than equal to 0, else it won't hold true. Given n, return the value of t of n. Basically, tnth term we are required to return when n is equal to 4. So how that Fibonacci number would be? We will be starting from 0, 1, and 2. So basically, for t third, the number would be 0 plus 1 plus 1. For second term, we are taking it as 1 only. So now t third term would be 2. And then for t fourth term, it would be 1 plus 1 plus 2. So ultimately, it will become 4. And this is what our output would be like. Now, in another example, when n is equal to 25, so like this only, first it will be calculating t third term, then calculating t fourth term, then t fifth, and after it reaches this t25 term, it will be calculating one by one for everyone. So this is how it will be calculating. Then your constraints are up to that n can go up to 37. Although this is pretty much lower constraint, but the way we will be doing this particular question, the way the answer will come up, it will surely lead to divide and conquer sort of solution where the time complexity could go up to exponential. And because of that thing only, that exponential time complexity will give us TLE with this much constraints as well. So that's why we would be required to optimize the same solution. Now comes the part that how the complexity would be exponential and how we can improve the same. So let us first go ahead with the brute force solution for the same. Basically, the way it is being added up, it simply indicates that this is a problem of divide and conquer, and we are required to solve it by that. And after that, basically that recursive problem which is there, that is surely divide and conquer, but we are required to improve that more and reduce its exponential time complexity to somehow to much lower. So that's the thing which we are required to do in this particular question. Now, uh, let us go ahead with the explanation for the same. So here, our third term would be something like T0, T1, and then T2, right? Addition of all these three will give us this third term. Our nth term would be like Tn equals to Tn minus 3, Tn minus 2, and Tn minus 1. This is how our nth term would be. So basically, it could be done iteratively or recursively, and it's a problem of divide and conquer. Here you can clearly see that we are dividing this particular into three portions: n minus 1, n minus 2, and n minus 3. So basically, because of this only, our time complexity here becomes rather exponential here. Basically, it would be as we are dividing it to three parts, and exponentially it could go up to n. So that's why time complexity becomes 3 raised to power n. And then how this particular recursive tree could be represented as a recursive solution. First, we require a base case. So our base case would be when n equal to 0, we will be returning 0. When n equals to 1, returning 1. And when n equal to 2, we will be returning 1. Because At first three elements which are there, those are fixed. That is the T0 term, that is 0, T1 term, that is 1, and T second term, that is 2. So instead of returning T0 term, we are required to return when n equal to 0, then we will be returning 0, when n equal to 1, then 1, and when n equal to 2, then we will be returning 1. So this is how the things would be. Now comes the part that this was the base case, but what about the main solution, that is our recurrence relation. So our recurrence relation would be, as we require here, t n is equal to tn minus 3, n minus 2, n minus 1, right? So according to this only, our function, and we will be putting n minus 1 term, then n minus 2 term, and then n minus 3 term. This is how we will be putting in our function and then adding them up, and after that, whatever result we will be getting, that would be our answer after the end of the all recursive call when it reaches this particular base cases. So this is how a recursive solution would be, means overview sort of thing. And then for iterative solution, basically then we are based here it is in recursive sense, but this particular would be giving us TLE, as it would be having a time complexity 3 raised to power n, right? So we will be required to modify the solution and memorize the same, and even that memorized solution could be turned into iterative DP as well. For that sense, again a zero term, first term, second term would be like this. So where DP of 0 would be equal to 0, DP of 1 equal to 1, and DP of 2 equal to 1, right? And our answer would be first adding up T2, T3, T0, T1, and T2. And then we will be running a loop from I equals to 3 to n. Here we will be adding up whichever last three terms which were there, that we will be adding up, and that will be answer for I term. And at the end, when I becomes equals to n, so at that point we will be easily able to get our nth Tribonacci number. So this is how we are required to do. But here the rather than exponential time complexity, here it becomes order of n. Time complexity and space complexity also order of n, because we would be using this dp, that is this would be a 1D vector which we will be using, and in that we will be having all the numbers filling one by one. So this is how we are required to do this particular question. Is from an exponential question we are turning it out to a linear question, linear time complexity one. And now comes the part that how we are required to code this particular question. So let us go ahead with the same. 1 minute. So, so this is for our recursive solution. Our recursive solution here, this is acting our base case, this is also acting our base case, and this is also acting our base case. The thing which I had already explained, that when n equal to 0, 1, or 2, then what we are required to return. So these three are acting as a base case, where a recursive tree would directly eliminate at that particular point and start returning to its parent. Now here, our recurrence relation is that we will be adding up whatever n minus 1, n minus 2, n minus 3 terms are there, and whatever these function would be returning to our present call, that we will be adding up and returning to its parent. So that's the thing which we are doing here. But this is the recursive solution. So this is the recursive solution, and that's why its time complexity would be exponential. That is, its time complexity would be order of 3 comma n, basically power of 3 comma n. So this would be its time complexity. And the space complexity here is as per the recursive stack. So recursive stack height, that would be its space complexity. So that would be about order of n only. So this was for the recursive solution. Now comes the part that how we are required to memorize this particular recursive solution. so that its time complexity decreases. So now here I've taken a what we say 1D array, and this array I've taken as up to the limit of 40. And why 40? Because as per the constraint we can see here 37 is there. So because of that, we are just adding up 3 to the same, so it becomes 40. So here, this is what I have taken. And now here comes the part, the main function which was there. So from this first function, we are here assigning the size of that particular array with -1 to the same. And then answer equals to solve of n, and the solve is basically a recursive function. And at the end, we will be returning our answer. So in this particular recursive function, what we are required to do here is, here first we are having same constraints which we used in that recursive function, but there we were directly returning. But here we are not returning, but directly we are assigning to that particular index of the array with that particular number which we were earlier returning. And here, if that particular portion is not equals to -1, means it has already a value, then we will be returning that particular number at this point. Else we will be returning the recurrence relation which was there while assigning that particular value to that index of the DP. And at the end, like this, our whole DP would be filled up completely, and that would be returned to this function, and it will be stored in this answer. And at the end, we will be returning that answer. So this particular question, no, sorry, this particular solution is having time complexity of order of n, and the space complexity here is again order of n. Here it become a linear because we have already memoized this thing. So this was about our memoized solution. He's basically memoizing the recursive solution. Now comes the part for the iterative version of this particular solution. So here, rather than using those recursive calls and so on, we are iteratively doing the same. So here I have taken this in this particular array where the size is up to n plus 1, and then if my n equal to 0, if my n equals to 0 or n equals to 1, then I would be returning n. Same goes with the case of 2. If it is 2, then I will be returning 1. Here I am assigning the values to my DP 0, 1 and 2. Basically these indices would be storing these values only. And then here I'm running a loop from 3 to n, and whatever last three digits which last three numbers which were there, I will be adding them up, and then after adding them up I will be storing to that particular index, and then at the end I will be returning dp of n, which will be having the nth Tribonacci number. So this was all for this particular solution, and the time complexity here also is order of n, and the space complexity also here is order of n. So this was all for this particular solution. I've explained the time complexity and space complexity also, and even how a recursive solution turns out to be a memoir solution, and how to change that memoir solution to an iterative one. So this was all. If you have any doubt, you could comment that down with that particular timestamp. And yeah, so thank you.